All right, here's the killer. Here's where you got to expand your minds. Told you guys this in class. We've got the inclined plane problem, and this one is going to help you to change your perspective a little bit. All right, we've got forces on this object. Right now, let's say there's no friction between the object and the inclined plane. Let's say that we don't even know the mass of this object. It's just m. All right, we're gonna use variables here, but let's say we do know that it's 30 degrees. It's fine. It's okay. It's a 30, 60, 90 triangle, and it has mass here, and we can draw the free body diagram. So let's go ahead and draw that free body diagram. What are my forces? One force, it's going to be the force of gravity. Very good. We're drawing that straight down. Okay, let me draw it actually a little bit bigger than I should. It really doesn't matter, but let's just draw it kind of big. Okay, that's my force of gravity. And we would calculate the force of gravity by taking m, multiplying by g, the acceleration due to gravity on objects with only the force of gravity. And that's it, you know? What other forces are here? If that's the only force there, then this is something in free fall. So we need one more force at least, and that's the force of, or that's the normal force. And normal means that it's perpendicular to whatever surface that we're talking about. Here's our normal force. Let's see if this green's going to show up for us. Does it? Yeah, it does. So there we go. There's our normal force. And which way is this thing going to accelerate? Because if there's no friction, then it's got to accelerate. And the way that it's going to accelerate, it's going to be down here in this direction. That doesn't say that it's moving in this direction, because we don't know which way it's moving. It could be moving up, it could be moving down, it could be still at the moment, but we do know that it's accelerating this way. So if it were moving up the plane, that means it's slowing down. If we're moving down the plane, then it's speeding up. If it were still, then it's about to move this way. And so here's the important part. Because we know that this thing is going to be moving eventually, most likely, hopefully, along this axis, I don't want to talk about the velocity in the x direction like we normally do. I don't want to talk about the velocity in the y direction like we normally do. I just want to talk about the velocity in this direction. And so it's going to be very beneficial for us to take our paper and to change our perspective. And so for some of you, it's very hard to do that. Just imagine, hey, this inclined plane didn't actually exist. This is just some random force. Happen to know it as gravity. But this needs to be okay for you. Okay, so we're going to change your perspective. And if we do that, then our new axis is here. So here's our x. Here's our y. You know, in math class, they always teach you guys, here's x, here's y, and you always imagine it as horizontal and vertical. They're just 90 degrees to each other. Right? They're just perpendicular to each other. You can place them wherever you want. And that's what we're doing here. We're making this problem easy for us. And so if you see this, you see that, hey, we have this force, this normal force, that's pushing out of the inclined plane. We have the force of gravity that's pushing into the inclined plane. Here's the component. Right there. We've got this force of gravity pushing down and to the right. Well, it has a component that's pushing it to the right in this direction. And what you need to do is you need to take your ruler and draw that component, or your ID, and line it up with that axis. You see what I'm doing? Line it up. Let's move it straight down. And there we go. And there's the component of gravity that's pointing down the inclined plane. All too often, students will draw their component of gravity like this, in this direction, which is not it's not changing your problem at all. So we want to change our problem. Actually, before if you did that, you just make your problem wrong. So here is my component of gravity, F, G, in our new y direction. Here's my component of gravity, F, G, in my new x direction. And the way we figure these out is we use some trigonometry. We have 30 degrees over here. This angle inside here, that's 30 degrees. Okay, that's the same angle out here. And we can prove it if you want to. You know, we can go over here and we can say, all right, let's just extend this thing. Let's draw something that's perpendicular to it. Let's extend this thing as well. Let's draw a horizontal. See if we can't prove this. Okay. So where's my 30 degrees? It's right there. Dink. Alright. That's 30 degrees. Well, this thing is like this thing right here. Well, what is this? You see how this whole thing is actually 90? So what is this? That's got to be 60, right? You see how this is also 90? Oh, let me try to straighten it up, sorry. So that's 60 if that's 90. Here's 90, and if that's 60, then this, right there, that's got to be 30. Okay? So there's your little proof. And so in this triangle, again, we got to find out the components of gravity. And this video is just over this. How do we find this? FGY. FGY. How do you find it? That side is adjacent to my angle. We have mg, which is my hypotenuse. And so, using trigonometry, adjacent hypotenuse AH, that's going to be CAH, that's cosine. And so, if I take my hypotenuse, mg, multiply by the cosine of my angle, that's going to give me FGY, that component. Likewise, if I want to talk about FGX, that is opposite my angle. OH, the hypotenuse. SOH, that's sine. MG, sine of my angle. That's FGX. And if you do sum of all forces, just to finish this off, the sum of all forces in the y direction, we want it to be 0. We don't want this thing to fly off. That's equal to normal force minus this thing, mg cosine of theta. Okay, those need to be equal to each other. The sum of all forces in the x direction, our new x direction, we don't know what it is, but we do know that this is the only force that's there. It's going to be mg, the sine of the angle, which is equal to, what is force equal to? MA. And what this says to us is that mg sine theta is equal to MA. M is on both sides here, it's the same M. If we take it away, the component of gravity, the acceleration due to gravity, is equal to our acceleration. Okay? And so, be very careful when you're doing these inclined plane problems. Make sure, whenever you rotate your axes, that you're rotating it with a purpose, and that this component is parallel to the inclined plane itself.